Hello YouTubers. This video is a small demo on how to configure alarm view and analog alarms. Please do not forget to like the video and subscribe to the channel. I have created a demo project to simulate alarms. Alarms are based on water level in the tanks. PLC monitors the level of water in water tanks and saves those process values in the data block. Alarm server of the comfort panel monitors those values, and generates errors, if process values leaves the working range. By getting error, operator also gets a message with more detailed explanation. In this example, each water tank can generate two errors, level is low and level is high. First one means, that water tank is almost empty. Another one, water tank is almost full. On each incoming error the counter of errors will be incremented, and on each outgoing error the counter will be decremented. Errors count will be represented in the text field of alarm button. Let's take a look at the PLC program. There is nothing special, as I am going just to monitor water level process values. For that purpose, data block DB7 is created. Here I store the values of water level of 10 water tanks. And that is that. Switch to comfort panel. Add one to the project if you have no any. I am working on my previous project, discrete alarms. It is a good practice to create a separate tag tables for different type of tags. I have created an additional tag table, water level. It contains process values of the levels of 10 water tanks, that are saved in the data block of the PLC. Click on HMI Alarms. Here you can see tab different type of alarms and settings. First tab is for discrete alarms. Second tab is for analog alarms. Third one is for controller alarms. Fourth is for system events. Fifth is used to configure alarm classes. And last one is for configuration of alarm groups. Let's configure alarm classes. Click on tab Alarm Classes to view it. There are 4 predefined classes, that cannot be edited. Those are errors, warnings, system alarms and diagnosis events. While you cannot change their names and state machine, you are free to edit display name, background color settings, logging and email address. Besides predefined classes, you can create your own, fully editable. In this example I am going to work with one class, errors. Background of incoming and outgoing errors will be red. It will signal for operator, that error needs to be acknowledged and additional measures needs to be taken. Background of the acknowledged active error will be orange. If the color of the incoming and acknowledged error does not change according to your setup, then you need to enable that option in runtime settings. In project tree, select runtime settings under your device. Switch to alarms, and check alarm class color checkbox under the general properties. Open analog alarms in HMI Alarms. Here I have 6 analog alarms for 3 water tanks. Each of the water tank has low level alarm and high level alarm. Set points for low level and high level are constants. For low level 10, for high level 90. Set point is set in the column limit, and in column limit mode is set the reaction to the set point. If you want alarm to be triggered when the limit is exceeded, then select mode higher. If you want alarm to triggered when the limit is undershot, then select Mode Lower. If you switch to the tab Info Text under the Properties, then here you can write down the information text for the operator. That text will be displayed when Info Text button is clicked. Let's switch to the main screen. Here I have 3 sliders to simulate the level of the water tanks. This button shows pop-up screen with alarm viewer component. Also, the button shows how many active alarms present. Background color of it changes according to presence of alarm. If there is at least one active alarm, then button background color becomes red. Like I have mentioned, alarm view component is placed on pop-up screen. Let's test this application. There are 3 alarms at the moment. All 3 tanks at low limit. By increasing the level of the tanks, the count of the alarms decrease. But they are still visible in the alarm view as they were not acknowledged. Let's look at more settings of the analog alarms. Switch back to analog alarms. The limits can be either constant value either variable. Let's create tags for variable limits. Assign these tags to form variable limits. Let's put some I/O fields with these limit tags on the main screen. Let's test the application. I will set different limit values for different tanks. As you can see, alarms for different tanks are triggered at the different limits that are set in the I/O fields. It may be so that process value fluctuates around a limit. In this case, the alarm associated with this fault may be triggered multiple times. To prevent this from happening, there are two settings: delay and deadband. Delay can be in milliseconds or in seconds. Let's try to set 10 seconds delay for tank 1 full limit. As you can see, third alarm arise with great delay. In some cases delay is not good option, as there might be high peaks of fluctuations that needs to be indicated as alarm. In this case a deadband setting comes in handy. Deadband can be configured for incoming, outgoing, or both. The value can be set in units or in percents. Let's set a deadband 20% for high limit of tank 1. As you can see, the alarm for tank 1 is not triggered until value fluctuates within deadband set point. That is all I wanted to show you about analog alarms. If you find this video useful, please do not forget to like it and subscribe to the channel. Thank you for watching and happy coding.